let's start.
All right, I'm ready.
Yeah, okay. I'm Alexandra Breyman. I'm Luxoft Professional Training Center expert in the area of architecture and data management.
All right.
Yeah. Hi, Eric. How are you doing?
I'm good.
Great. Today our topic is serverless computing, and our guest is Ericom Johnson, evangelist for Amazon Web Services at Rackspace, or should I say developer advocate, or
yeah, so I actually work for AWS. I'm a developer advocate. I'm a senior developer advocate for serverless at AWS. I think there's some confusion. Just real quick, last time I spoke with this group, I worked for Rackspace, but I've since changed. So just so you all know, I actually work with AWS now.
Okay. So every time we develop a piece of code, it's intended to be put in some memory and run by CPU. So we ultimately need a computer to execute it, a server. But where is the server and the serverless? Is it hidden or just not existent? Everything runs on client device or something?
So it's a question I get a lot, and it's a debate that goes on. So at AWS, when we use the term serverless, we use it to refer to services that provide automatic scalability, are highly available and secure, require no infrastructure provisioning or management, and are provided on a pay-as-you-go basis to our customers. So that's kind of when we talk about serverless. While yes, there are servers backing these services, the management of the services are handled by really a world-class engineering team at AWS. So examples of these services include AWS, Lambda, which is kind of the, that's the flagship there when we talk about that. Amazon API Gateway, DynamoDB, step functions, and our newest service, which is called EventBridge. So, as you know, yes, there are services, but that's abstracted away from the user, and they don't have to worry about it.
Okay. So they are present, but in some way hidden from.
Yes, that's a good way of saying it.
Yeah. Okay. A few years ago, serverless approach promised easy automated infrastructure provisioning. You don't need to think anything about your infrastructure. You just write the code, give it to us, and we run it every time it need to be run. Simple application upgrades. You just need to send us your new upgraded code, and that's all. Platforms provide comprehensive security tools. You don't need to think about security, as we all know that letter S in IoT, in Internet of Things, stands for security.
Yeah. So, I read that article too.
Yeah. And probably the best point in this list is cost cutoffs. You pay as you go. You don't need to pay for extra hardware, for extra time. So what successful use cases we can look at today to have a proof for that claims?
Yeah, so that's a little bit of a longer answer, and I'll give the team. The one thing I would talk about, when we talk about security, first of all, and the security is priority to us. Yes, the security is there, but I'm sorry. Yes, we build security into the infrastructure, but I want to point out, and a lot of times people have this idea: if I just put it on serverless, it's secure, but your code still needs to be secure, right? It has to be. You have to build a secure application as well. But so that's something to point out. But when we talk about infrastructure management and automation, service technologies at AWS are built around the idea that infrastructure is managed as code, right? Or what we call IAC, or infrastructure as code. No longer are operation teams required to provision and configure infrastructure for applications. With serverless, adding or modifying infrastructure is as simple as modifying a template file. So we talk about this promise of easier upgrades, easier changes. Since infrastructure is now managed as code, These changes can be automated with the same technologies that are in place for code deployment automation. So you see that simplification coming in. It is this flexibility and agility of serverless architecture and the low operational overhead and decreased cost that prompted companies like Sunday Sky. When we're looking for use cases, we have a company called Sunday Sky who adopted serverless for their video rendering application. Sunday Sky is an AWS customer who's providing an end-to-end video platform that transforms customer relationships through personalized videos. They adopted a serverless approach with AWS while refactoring a large part of their monolithic video generation and delivery platform into separate, more manageable microservices. And by simplifying and isolating each part of the architecture and managing that architecture as code, Sunday Skies now has a much simpler, continuous deployment flow that allows way faster time to test and deploy new features. Furthermore, they reduce the cost of running customer-specific business logic by 60%. Compared to their monolithic platform. So when you're looking for use cases, the best thing we can do is say, hey, here's what our customers are doing. Another customer, their name is Speed Shift Media, and they provide advertising agencies with like turnkey managed advertising solutions. They migrated from a legacy monolithic application to a serverless application. So again, they're moving from monolithic to serverless or microservice application, creating increased productivity and cost savings of more than 25%, and data processing that is 99% faster. And so when they move into a serverless realm and you have that serverless scalability that scales with your application, they were able to move, to increase their speed by 99%. So it's a pretty good number.
Great, thank you.
Yeah.
So developer productivity is one point that very influenced by serverless and about some weak points of serverless, classical weak points. For example, slow start. If I just put my code and say run it, and user will come in, and then it will start a few maybe seconds, maybe more later. What about cold start of my serverless, of my lambdas in modern architectures?
So when we talk about cold start, so just for definition, a cold start means, hey, my lambda is no longer warm. We keep lambdas warm outside of a VPC for 5 minutes, inside of a VPC for 15 minutes. So if you're running an application that just hits your lambda every 6 minutes outside of VPC, or then you have cold starts. If you're running and outside of VPC and cold starts can be affected by quite a few different things. The language you're using, how large is your code aspect, your code footprint, and different things like that. Outside of VPC, your cold start is going to be, it's in the milliseconds usually, maybe 1 or 2 seconds at the top end. Then once it's up, then the subsequential hits are on that are going to be very fast. Again, based on how you cache, based on your application. So there are definitely ways to work with the cold start, but that is part of the process of starting the lambda, and if it's not a warm lambda within the VPC, it can take a little longer because we're doing some security connections. One of the things I often ask folks is they come to me like say, hey, we put everything in a VPC because and you're an architectural expert, this, you always have layers of security, right? If you're going to build something, you put it in a VPC. Lambda is a little different in the fact that it's already in a VPC. So we don't recommend putting Lambda in a VPC unless you have to connect to other services that are in a VPC. If that makes sense. And for those of you who are watching, VPC is virtual private cloud. That's one of your first layers of security in AWS. But in serverless technologies, that's again, unless you're connected to server full technologies in a VPC, you don't have to worry about that. Does that help?
Oh, I see. Yeah, thank you.
Yeah.
Most functions in serverless, most lambdas, are more granular, just microservices. They just quite compact and need to be run quite fast. What are the best practices in dealing with that multitude of tiny code pieces? How to deploy, update, to combine them, problem, monitor them, how to deal with multitude of tiny code pieces.
Yeah, serverless, like anything else, when you deal with a lot of code, you want to have a good practice, on that. Regardless of the technology, application architecture or code management is really a personal choice between a development team and their code. You watch developers and they get really, set on how they want to do it. When I work with developers, I encourage them to evaluate their code by several different factors. Excuse me. And this will help them when they're making decisions. But the first thing I would say is observe the following development principles, which to me are simple responsibility model, which a Lambda function should only do one thing and do it well. Do not repeat yourself, which is dry. If you are doing the same thing twice, share the code instead of duplicating it, and then keep it simple. I always learned up when I was a kid. I learned keep it simple, silly. Or keep it simple, stupid, which is KISS, depending on if they were insulting me or not. But, if your code becomes too complicated, break it into smaller chunks. Because you're right. When we're looking at microservices, we want to keep them simple. I do one thing and I do one thing really well. And so by observing these principles, I now start to have a collection of code that should include Lambda functions that do their one task, and shareable supporting code in the form of maybe like clients or libraries, etc. And I generally see the Lambda functions as microservices and a collection of Lambda functions as an application. So when I have that, when I've kind of walked through that, then the next step is to figure out how to separate the application, logically. For like a REST API, I'll split applications by their routing. For example, I might have a path like, mydomain.com user, and the user path will be a single application that handles, all actions related to the user, like a domain object. And this isn't uncommon. This would be something you would see outside of the serverless world as well. It's a normal pattern. It's by this segmentation that I'll package my application and I'll store it. So what I've got is I've got that one domain, object, user, I'll package that, and that'll be my Git repo. One repository equals one application. As far as sharing my code, this is a longer answer, sorry, I'm long-winded on this. As far as sharing my code across Lambda functions in applications, I'll make use of Lambda layers. Now, Lambda layers is a technology that we have where you can use libraries in your function without needing to include them in your deployment package. And it allows you to say, all right, I have 7 Lambdas. I have one piece of code that I share between those 7. So when I update, or when I create or update those Lambdas, I'm going to include this layer and it'll have those shared libraries. So it's a great way of managing the microservices and then the smaller bits of shared code and such. So
our Moscow workshop at 7th of October is about serverless. So who will benefit most from this seminar? Is it intended to be useful only for AWS users or not? Or it's just you'll show common practices, common techniques, and what are expected outcomes for people who will come to our workshop in 7th of October?
Yeah, so this will be AWS specific because I'm an AWS guy, and that's when we talked about doing this and bringing me in. I'll be teaching AWS technologies for sure, and it will benefit anyone from a new user who has never created a Lambda function to an expert who is using serverless technologies on a daily basis. By the end of the session, you'll understand how different serverless services come together to make a serverless application. And that's what the workshop will look like, as well as the sessions. You'll be introduced to tools like, let me try that again. You'll be introduced to tools like SAM, which is our same serverless application model that are used in building serverless applications. And you'll have hands-on experience creating a serverless application, including advanced topics like, publish and subscribe with SNS and SQS, like, pub sub, if you're familiar with that technology, SQS for queuing, Event Bridge for event triggering, a lot about event-based architecture. As well as managed artificial intelligence and machine learning with Amazon Translate and Amazon Poly. Those are easy services to roll into serverless applications. So in our examples, we'll be talking about some of those as well.
Okay. So probably I'm run out of questions.
Okay.
So Eric, thank you very much for the interesting and I hope fruitful conversation, for your answers, and meet you in Moscow in October. Thank you very much.